In this session, we are going to discuss a very important part from the quantitative aptitude section of bank exams, and this is called number series. Generally, the weightage given to number series in bank exams is 5 marks, and this topic tests the observation and analytical skills of the candidate. A number series is nothing but a collection of numbers or a ordered sequence of numbers where each number or each term follows a predefined rule. And based on this rule, we can find out the succeeding terms of the given series. The most important part in solving a number series question is identifying the logic or the predefined rule behind the given series. Once we understand the logic, then getting the answer becomes really very easy. And since there are infinitely many logics in which the number series question can be given, there is no definite formula or method to get the answer here. So I can say that solving a number series question is based on getting the right idea at the right time, since it is completely based on the perception of the candidate. So in this session, we shall take up various questions from this topic of number series and try to understand what is the logic behind them. Before we take up any questions from this topic, let me mention one very important point regarding number series. Whenever we solve questions from number series in the exam, make sure that you don't spend more than 30 to 45 seconds in getting the answer. That means if you are able to get the answer within 45 seconds, well and good. Otherwise, simply leave the question and move to the next one. Why? Because there is no definite method here to get the answer. So if you are not able to solve it in the first 30-45 seconds, then there is no point in wasting further time on that. So make sure that you restrict yourselves to 45 seconds while solving questions from number series. Generally, we get only two types of questions from number series. One is where we have to find out the missing number, and the other one is where we have to find out the wrong number. Now, in case of a missing number, a series of 5 or 6 terms is given to us and we are supposed to find out the next one. So that can be done based on the logic behind the series. So we have to just try and understand what is the predefined rule or the logic in that series and find out the next term. And in the second case, where we have to find out a wrong number, a series of again 5 or 6 numbers is given where one of the numbers does not fit in the series. Here again, we first need to understand the logic behind the series and then identify which of the given terms is wrong. Generally, finding out the missing number is easier compared to finding out the wrong number in the series. But as I've already mentioned, whatever be the type of question, you restrict yourselves to 30 to 45 seconds. If you get the answer, well and good. Otherwise, simply leave the question and move to the next one. Let us now take the first model from this topic of number series, where we are going to discuss all the trivial series which can be asked in the exams. Now generally, when a series is trivial, the answer can be obtained within no time. Let us have a look at some of the examples and understand what is the logic behind them. Now, as you can see here, the first example is 1, 2, 3, 4, 5, 6 and question mark. So here we are supposed to find out what comes in place of the question mark. As you can observe, this is a very simple series which is nothing but natural numbers. 1, 2, 3, 4, 5, 6 all are natural numbers. So obviously the next number which comes after 6 here has to be 7. So the answer for question number 1 here is 7. The second example here is 2, 4, 6, 8, 10, 12 and question mark. So again, we are supposed to find out what comes in place of question mark. As you can see here, this is nothing but an even number series which consists of consecutive even numbers. So the number which comes after 12 has to be the next even number, which is nothing but 14. So the answer for question number 2 here is 14. The third example says 1, 3, 5, 7, 9, 11 question mark. So again, our job is to find out what comes in place of question mark. As you can observe, these are all consecutive odd numbers. So the next consecutive odd number that we have after 11 is 13. So answer for question number 3 here is 13. Moving on to the next one, it is 4, 8, 12, 16, 20, 24. So what comes after 24? I hope you all have got the idea. That's nothing but 28 in place of question mark. Why? Because these are all multiples of 4. 4, 8, 12, 16, 20, 24. So the next one has to be 28. That is nothing but 4 into 1, 4 into 2, 4 into 3, 4 into 4, so on up to 4 into 8. Likewise, the given series may be multiples of any integer. Instead of 4, 8, 12, we may have 6, 12, 18, 24 and so on. So it's only that we should be able to understand that these are multiples of 4 and then find out the missing term. The fifth example here is 1, 4, 9, 16, 25, 36, and then we have a question mark. Now can you tell me what comes in place of question mark here? I hope you all have got the answer. As you can observe, these are nothing but perfect squares of natural numbers starting from 1. For example, 1 here is nothing but 1 squared, 4 is 2 squared, 9 is 3 squared, 16 is 4 squared, 25 is 5 squared, 36 is 6 squared. It is obvious that the next one has to be 7 square. Why? Because that is the rhythm here. As I've already mentioned, we only need to understand the logic behind the series or the rhythm in that series. So as per the rhythm here, the next one has to be 7 squared, which is 49. So question mark should be replaced with 49. Likewise, if you observe example 6 here, the series is 1, 8, 27, 64, 125, 216. So what do you observe? These are all perfect cubes of natural numbers again. 1 is 1 cube, 8 is 2 cube, this is 3 cube, 4 cube, 5 cube, and 216 is 6 cube. So it is obvious that the next one has to be 7 cube. 7 cube, or that is nothing but 343. So question mark should be replaced with 343. And the last example in model 1 is 2, 3, 5, 7, 11, 13 and question mark. Now what do you observe here in the series given in example 7? Try to understand the rhythm in the series. Try to understand the logic behind that. What do you observe? 2, and then we have 3, 5, 7, 11, 13. So what do you think should be the next one? Now if you observe, those who have got the right idea, they know that these are all consecutive prime numbers. 2 is the first prime number. Then we have 3, 5, 7, 11, 13. And the next one here has to be the prime number which comes after 13. What comes after 13? 17. So question mark has to be replaced with 17. That is nothing but a series of prime numbers. So these are some of the examples from model number 1 where we have discussed various trivial series. And as you can see, the logic here is very simple to observe. So it's just about understanding the logic there and finding out the missing number. And as I've already mentioned, the other type of question that can be asked here is finding out the wrong number, where the series will be given and we are supposed to find out which of the numbers is wrong. For example, let's say the series is as follows: 1, 4, 9, 16, 26 and 36. And we are supposed to find out which one of these numbers is wrong, or what is the odd number here which does not fit into the series. Now again, as I've mentioned earlier, we have to identify the rhythm of the series and then understand which of these given numbers is wrong. So what do you observe in 1, 4, 9, 16, 26, 36? Which number do you think is wrong here? If you have got the idea, you clearly understand that 26 is the odd one out. Why? Because all the remaining numbers here are perfect squares. For example, this is 1 squared, the next one here is 2 squared, 3 squared, 4 squared. So as per this series, the next number has to be 5 squared, which is 25. But the given number here is 26. Hence we say that 26 is the wrong number. And that is the answer for this question. And 36 is nothing but again 6 squared. So 26 is the odd one out, or 26 is the wrong number. So likewise, for all the remaining questions as well, the question can be asked in terms of finding out the wrong number. So there again, we need to understand the logic and find out which of the given numbers is wrong. So that is what is number series is all about. We have to understand what is the logic and get the answers. So the point to be understood here is, though all these examples show you trivial series, the same can be made complicated if we start from a larger number. Even in case of squares and cubes, we have seen that we started from 1 square, 1 cube and so on. But otherwise, if we start from 16 square or let's say 16 cube, the same logic will take more time for us to understand. So make sure that you think in all possible directions in that limited time to get the right answer. And as I've mentioned, it is all about getting the right idea at the right time. So the more you practice, the easier it becomes. Let us now take the second model from number series, where we are going to discuss questions based on AP, GP and HP. That is nothing but arithmetic, geometric and harmonic progressions. Let us look at some examples here. Now the example 1 here is 9, 16, 23, 30, 37 question mark. So we are supposed to find out what comes in place of question mark. As I've already mentioned, it is all about understanding the logic behind the given series. That is to understand what is the rhythm behind these numbers to find out the missing number. So let us now observe the series and try to understand what is the logic behind the given numbers. Now as you can see, the numbers are 9, 16, 23, 30, 37 and question mark. If you try to observe the difference between two consecutive numbers, we find that 9 and 16, that means 9 plus 7 gives 16. Then 16 plus 7 will be equal to 23. 23 plus 7 is 30 and 30 plus 7 will be equal to 37. That means very clearly the difference between two consecutive numbers here is equal to 7. So we can say that the next number here, which comes in place of question mark, should be 37 plus 7. That is nothing but 37 plus 7, and 37 plus 7 will be equal to 44. So that will be the missing number for the given series. So here we find that the difference between two consecutive terms is always 7, and such a series is called as arithmetic series. So an arithmetic series is nothing but where the difference between any two consecutive terms is a fixed value, as 7 in the given case. So once we understand that this is the logic there, we can simply find out the missing number as 37 plus 7, that is equal to 44. Let us now look at the next example, that is 67, 58, 49, 41, 31, 22. And here we are supposed to find out which of the given numbers is wrong. It is not about finding out a missing number, but instead we need to find out of these given numbers which is the wrong number, or which is the number which does not fit in this series. Again, here also we need to identify the logic behind the given numbers. Now this is actually a decreasing series. The numbers are decreasing gradually. Like in the previous case, the numbers were increasing gradually. Here we have the numbers which decreases one after the other. Again, let us try to observe the difference between these numbers. As I've mentioned, there is no particular rule or method to get the answer, but we're just trying to understand the logic by checking the differences between two consecutive numbers. Now when we look at 67 and 58, we understand that 67 minus 9 is equal to 58. That means 67 minus 9 will be giving the next number 58. Again, 58 minus 9 is 49. 58 minus 9 is 49. So by looking at the first two differences, we feel that maybe the difference here is always minus 9. The difference between two consecutive terms here may be minus 9. But when we proceed, we find that 49 minus 9 should give us 40. But the given number here is 41. So maybe 41 here is the wrong number. But simply here itself we cannot say that 41 is wrong. We also need to confirm that by looking at the various other numbers. So assuming that minus 9 is the pattern here, or minus 9 is the logic here, let us continue and see if 31 and 22 are the right numbers with respect to 40 or not. Now if we take 40 as the correct number in place of 41, then again going forward we'll have 40 minus 9, that is equal to 31. And 31 minus 9 again will give us 22. So here we find that the difference between two consecutive terms is always minus 9 except in case of 41. So 41 is the wrong number. 41 will not fit in this series. Instead, we should have 40 as a correct number there. So we can say that the wrong number here is 41. Even in this case, you find that the difference between two consecutive terms is constant. So this is also a case of arithmetic series, where the difference between two consecutive terms is a constant value. So from these two examples, it is clear that questions may be given either in terms of missing number or in terms of finding out the wrong number. In both the cases, we need to identify the logic behind the given series and find out the missing number or the wrong number as per the given question. We also observe in these two examples that the series is either gradually increasing or gradually decreasing, and both are arithmetic series cases. So whenever you find that a series is increasing gradually or decreasing gradually, just try to understand the difference between two consecutive numbers. If the difference comes out to be a fixed value, then it is definitely an arithmetic series case, and accordingly we can either find out the missing number or the wrong number. Let us now take the next set of examples from model 2 of number series, where the series are based on geometric progressions. That is nothing but the ratio between two consecutive terms of the given series is a constant value. Let us look at some examples and understand this. The first example here we have is 14, 70, 350, question mark, 8750 and 43750. So as you can see here, we need to find out what comes in place of the question mark. Now if we try to observe the numbers here, they are increasing sharply. Like in the previous case of arithmetic series, the numbers were increasing gradually. But here we find that the numbers increase exponentially, or I can say they increase sharply. That is, there is a sudden jump in the numbers. Like 14 becomes 70, 70 becomes 350. Then we have 8750 and this becomes 43750. So there may be a chance that the ratio between two consecutive terms is a common value or it is a constant value. So let us understand what is the ratio between two consecutive terms of the given series. Or that is nothing but if each number when multiplied with a fixed value gives us the succeeding number. For example, 14 into 5 will give us 70. So we can say that 14 when multiplied with 5 gives the second term 70. Likewise, 70 when multiplied with 5 gives the third term 350. So there is a chance that into 5 is a common ratio, or nothing but when each term is multiplied with 5, it gives us the next term. So according to that, the question mark here should be nothing but 350 into 5. That is again multiplied by 5 should give us the value of question mark. So this should be equal to 350 into 5. And 350 into 5 will be equal to 1750. But again, as I've mentioned earlier, here itself we cannot say that 1750 is the answer. If this 1750 justifies the remaining two numbers as per the multiplication with 5, then only we can say that it is a correct answer. Otherwise, we may have to look for some other logic behind the given series. So let's see whether 1750 into 5 gives us the next term or not. Now 1750 into 5 will be equal to 8750. 1750 into 5 is equal to 8750. And similarly, 8750 into 5 will be equal to 43750. That is 43,750. So very clearly, the ratio between two consecutive terms here is common. Or we can say that when each term multiplied with 5 gives us the next term. By the term ratio, we mean that 70 by 14 is 5. 350 by 70 is 5. Similarly, 1750 by 350 is 5. So we can either say that the ratio is common or each term is multiplied by a fixed value to get the next term. Such a series is called a geometric series. So whenever, friends, you find that a series is increasing sharply, you just try to observe if there is a common ratio between two consecutive terms. And if you're able to identify that, it will be easy for us to find out the missing number. And as I've already mentioned, if you are not able to get this idea within 30 or 45 seconds, it is better that you leave it and go for the next question. Why? Because there is no guarantee that we'll be getting answers for number series questions, as logics are infinitely many. So we just have to go for a trial and error method for 30-45 seconds for questions like number series. And if you practice more on these type of questions, there are fair chances that you will get the right answers in the right time. Let us now take another example here. 8,000, 1,600, 320, 64. And what will be the next term? Again, here we have to find out the missing term. Now if you observe, even this series is similar to example number 3. That is, here also when each term multiplied by a common value gives us the next term. But the point to be observed here is, here it is not an integer that we are multiplying to the term, but in fact it is a decimal value. For example, 8,000 into 0.2 will give us 1,600, or that is nothing but 8,000 into 1 by 5. 8,000 divided by 5 is equal to 1,600. Similarly, 1,600 into 0.2 will be equal to 320. 320 into 0.2 will be equal to 64. So here we can say that the next term can be obtained when 64 is multiplied with 0.2. Why? Because so far we have observed that each term when multiplied by 0.2 gives us the next term. So that has to be the logic behind the given series. So 64 into 0.2 is equal to 12.8. So we can say that the question mark here will be equal to 12.8. So as you can see, either we can take it as into 0.2 for all the terms, or it can be taken as into 1 by 5. Or you can also understand it as divided by 5. Each term when divided by 5 gives us the next term. For example, 8,000 divided by 5 is 1,600. 1,600 divided by 5 is 320. 320 divided by 5 is 64. So 64 divided by 5 will be equal to 12.8. So these are the questions which are based on geometric series, where the multiplication factor between two consecutive terms is always a fixed value. So by enough practice, we should be able to understand that the given series is in terms of a geometric progression, and we should be able to find out the missing number or the wrong number. Here again, the questions may be given in terms of finding out the wrong number. So we again have to find out the logic in terms of geometric progression and identify the wrong number out of the given series. Let us now take the next example from model 2 of number series. And here the given question is based on harmonic progression, We know that harmonic progression is the one where the reciprocal of the given series are in a particular pattern. Let's take an example to understand that. Now the question here is 1 by 3, 1 by 7, 1 by 11, question mark, 1 by 19 and 1 by 23. And we're supposed to find out what comes in place of question mark. If you try to take the reciprocal of the given series, that means the inverse of the given values. 1 by 3 here is 3, 1 by 7 reciprocal is 7, 1 by 11 inverse is 11. And question mark has to be calculated. Then 1 by 19 gives us 19 and 1 by 23 gives 23 as the inverse. That means here if you try to observe the inverse of the given series or the reciprocal of each of the terms of the given series, we find that the difference between two consecutive terms is a common value or it is a fixed value. For example, 3 plus 4 is 7, 7 plus 4 is 11. And likewise 19 plus 4 is 23. So now we can understand that the difference between two terms here seems to be a constant value, that is nothing but 4. So if we try to take 11 plus 4, we should get what comes in place of question mark. We know that 11 plus 4 is 15. And if we try to cross verify, 15 plus 4 again gives us 19. That means in the complete series we find that the difference between two consecutive terms is always 4. So with that, we can say that 15 should be the one which comes in place of question mark in the inverse series. Now if 15 comes in place of question mark, when we take the reciprocal, what comes in the original series should be 1 by 15. So that is our answer. That is 1 by 3, 1 by 7, 1 by 11, 1 by 15, 1 by 19 and 1 by 23. Such a series is called harmonic progression where the difference between the reciprocal of the given numbers is a fixed value. So friends, from the various examples that we have taken in model number 2, we have seen that the given series may be an arithmetic series or a geometric series or a harmonic series. It is just that we need to feel the rhythm of the series and identify what is the logic behind that. If we are able to do that successfully in 30 seconds, then we'll get the right answers. Otherwise, there's no other option but to leave the question. And from these various examples of model 2, we can understand that it's all about understanding the relationship between two consecutive terms of the given series to identify the logic. So practice well on these type of questions and make sure that next time when a series is given in terms of arithmetic, geometric or harmonic progression, you don't miss out on it and quickly get the right answer by understanding the proper logic behind that. Let us now take the third model from this topic of number series where we shall discuss various questions based on different logics apart from whatever we have discussed so far. As you have seen in model number 1, we have taken all kinds of trivial series, and in model 2, we have taken series based on arithmetic, geometric and harmonic progression. But now we shall take up series where the logic changes with every series. And as I've mentioned, it's all about understanding the logic in that limited time and getting the answer as per the given question. So let's take some examples and understand various types of other logics. The first one here is 705, 728, 774, question mark, 935 and 1050. And it is obvious that we need to know what comes in place of the question mark. Now, as you can see here, generally to solve questions from number series, we first of all need to concentrate on the difference between two consecutive terms. Most of the times, by understanding the difference, we will be able to identify the logic between the different terms. So let's take up the difference between these terms and understand what is the probable logic. For example, if we take the first two terms, 705 and 728, we find that this is plus 23. That means 705 plus 23 gives 728. Then 728 and 774, we see that the difference here is 46 or nothing but 728 plus 46 will be equal to 774. Now as soon as we see these two differences, something has to strike to our mind. That is, the first term here is 23 and second one here is 46. If you observe properly, this is nothing but 23 into 2 and this can be taken as 23 into 1. So this may be the possible logic behind the given series. If you observe, this is 23 into 1. Second one is 23 into 2. So if the next one satisfies 23 into 3, 23 into 4 and so on, then we will be able to find out the right answer. Otherwise, we may have to look for some other logic behind the given series. So let's go ahead with 23 into 3 and see if we are able to justify the given series. 23 into 3 is nothing but 69. So 774 plus 69 may be the next term. So this question mark here can be taken as 774 plus 69, which is nothing but 843. Therefore, the question mark here as we have obtained is 843. Now let us go ahead with the series and check if 935 and 1050 are obtained as per the pattern or not. Now if this is 23 into 3, the next one has to be 23 into 4. 23 into 4. 23 into 4 is equal to 92. So let us take plus 92 and see if it balances or not. 843 plus 92. 843 is 9 plus 92 is 935. Hence, this is the correct answer. We can also check with the next term. That is nothing but 23 into 5. 23 into 5 is nothing but 115. And 935 plus 115 gives us 1050. So very clearly the logic behind this series is 23 into 1 plus 23 into 2 plus 23 into 3 and so on. That is nothing but the difference between two consecutive terms here are multiples of 23. And hence we can say that the question mark should be 843. So that's the answer for the given question. So very clearly we can understand that to solve questions from number series, we need to check up the differences between two consecutive terms and also think divergently. For example, 23 is not 23. Here it is actually 23 into 1. And then 46 is not 46. It's like 23 into 2. So this way, if you try to think in various ways, we may get the possible logic behind the given question. Let us now take one more example and see what is the answer for this one. The question here is 200, 231, 264, 299, question mark 375. Again, we see that the series is gradually increasing. Like in the previous case, the series was again gradually increasing. So here also the series is like increasing gradually. There is no jump in the number there. So let's go ahead with the differences between these numbers and see if we can get a possible rhythm between these differences. 200 plus 31 will give us 231. Then 231 plus what gives 264? 231 plus 33 will be 264. 264 plus 35 will be 299. Now if you try to observe the differences here, 31, 33, 35. So it is pretty obvious that we have got the logic. These are all odd numbers starting from 31. That is 31, 33, 35. The next one has to be 37. So let's go ahead with 37. 299 plus 37. 299 plus 37. So the question mark should be equal to 299 plus 37. That is nothing but 336. So let's say the question mark is equal to 336. And remember, before we mark the answer, we need to make sure that the next one also satisfies. So if this is equal to 336, we can say that the next term must be in terms of 336 plus 39. And 336 plus 39 is equal to 375. Hence, 336 has to be the correct answer for the given question. So in the previous example, we had seen that the differences were multiples of 23. And here we find that the differences are all odd numbers starting from 31. Likewise, the differences can be multiples of any other number instead of 23. It can be 12 or 14 or 6 and so on. And here also the differences may be odd numbers starting from some other value. Let's say 37 or 71 and so on. And it may also be possible that the differences here are even numbers starting from some value like 84 or 32 or 24 and so on. So that's how we can solve questions from number series based on differences between the two consecutive terms. But let me add, friends, it may not always be based on the differences between two consecutive terms. There can be various other logics possible as well. But most of the times we can go ahead with the differences and understand what is the logic behind the given series. Let us now take up the next set of questions from model 3. So here we see that we have got the next three examples, that is example 3, 4 and 5. Now example 3 is 3, 5, 8, 11, 17, 23, 30. And here we are supposed to find out what is the wrong number out of the given numbers, or what is that number which does not fit in the series here. Now as I have mentioned, let us first go ahead with the differences between two consecutive numbers. We find that 3 plus 2 gives 5. 5 plus 3 is 8. But again, when we take 8 and 11, we see the difference is 3. 8 plus 3 is 11. 11 plus 6 is 17. 17 plus 6 again is 23, and 23 plus 7 is equal to 30. So far the differences between the numbers here are as shown: 2, 3, 3, 6, 6 and 7. But if you try to observe the differences here, they are not in a particular fashion. There is no rhythm between these differences. And we already know that one of these numbers is wrong. So what should be that number here due to which the rhythm between these differences is lost? If we are able to identify that, then our job is done. Now if you try to observe, but the difference between first two numbers is 2. 3 plus 2, 5. 5 plus 3 is 8. Now let's assume that the logic here is plus 2, plus 3, plus 4, plus 5 and so on. We may be wrong, but we have to go ahead with one particular trial and check if there is any error or not. So let's go ahead with the logic, assuming that it is plus 2, plus 3, plus 4 and so on. If you try to observe, if this is plus 2, plus 3, if this is taken as plus 4, plus 5, then this will be plus 6 and plus 7. That means there is something wrong between these two differences. If these are taken as plus 4, plus 5, then the complete series here has got a fashion, has got a particular rule. That is, the differences are all natural numbers starting from 2. So let's say this should be 8 plus 4. If it is 8 plus 4, what we get here will be 12. And if it is 12 plus 5, then what we get next will be 17. So understand that 3 plus 2 is 5, 5 plus 3 is 8, 8 plus 4 is 12, 12 plus 5 is 17. 17 plus 6, 23, 23 plus 7 is 30. That means these two are the wrong differences. The actual series here is based on the differences 2, 3, 4, 5, 6, 7. And by that, we are able to understand that 11 is the wrong number and the correct number there should be 12. So the wrong number here is the number 11. But again, friends, let me tell you, all of us need not get this right idea. Some of us may get it and some others may not get that. It is only that we should be able to get the right idea at the right time. And remember, you need not spend too much time while solving these questions. If you are able to get this logic, well and good. Otherwise, simply leave it, as there is no other way out to get the answer apart from trial and error method. We have only tried with something. If that satisfies, well and good. Otherwise, we have to go for some other logic. But then we waste a lot of time in checking with various other things. So 30 seconds, 45 seconds is the time limit that all of us have to follow while solving questions from number series. And especially when it comes to series where you have to find out the wrong numbers. Why? Because in such series, we have no idea which of the given numbers is wrong. So it becomes a little difficult to find out the logic there. Let us now take the next example, that is 18, 21, 16, 23, 12, 25, question mark. We are supposed to find out what comes in place of question mark. Now if you try to observe the numbers here, 18, 21, 16, 23, 12, 25, that means these are like increasing, decreasing, increasing, decreasing and so on. So that's the flow of the series. It increases, decreases, then increases, decreases, increases. And next one probably has to be a lesser number, a decreased number. Now let us go ahead with the differences between these numbers here. 18 plus 3 is 21. 21 minus 5 is 16. 21 minus 5 is 16. 16 plus 7 gives 23. So far, if we try to observe the differences here, they are like plus 3 minus 5 plus 7. So next one has to be a negative difference. That means 23 minus something should give us 12. Now if we try to look at the magnitude here, 3, 5, 7, we feel that it may be 3, 5, 7. The next one has to be 9, 11 and so on. So let's go ahead with 9 and check if it is balanced or not. 23 minus 9. 23 minus 9 is 14. But the given number here is 12. That means very clearly the logic that we are trying to apply here is not satisfying the given series. Why? Because the magnitudes here are all odd numbers starting from 3. So the next one, if we take it as minus 9, 23 minus 9 will be 14. But the given number is 12. That means very clearly the trial that we have made with odd numbers is the wrong one. But anyway, let's go ahead and try to understand what is the difference between these two numbers. Why? Because here, anyhow, we have to find out the missing number. There is nothing which is wrong in the series. Had there been anything wrong, we would have changed this number here. But as the question is about finding out missing number, let's go ahead with the differences. 23 minus 11 gives us 12. And 12 plus 13 will give us 25. Now if we try to observe the differences here, plus minus plus minus plus, so obviously next one has to be minus. Why? Because they are like increasing, decreasing, increasing, decreasing and so on. If you now try to observe the magnitudes, that is 3, 5, 7, 11, 13. So what do you think should be the next one? What is the fashion here, or what is the pattern which the differences here is following? If you observe 3, 5, 7, 11, 13 are all consecutive prime numbers. Yes or no? 3, then 5, then 7, then 11, and then 13. All these are prime numbers. So it is obvious that the next one also has to be the next prime number. So after 13, the next prime number that we have is 17. So 25 minus 17 should give us the answer. So 25 minus 17 is equal to 8. So we can say that the question mark will be equal to 8. Remember friends, earlier we thought that the logic is 3, 5, 7, 9. But that failed for the next number. Hence we have tried with something else. And now we observe that these are actually all consecutive prime numbers starting from 3. So going by that, we find that 25 minus 17 should give us the value of question mark, which is equal to 8. So 8 should be the answer for this question. So this is how number series is all about, the right idea at the right time. You have to try with something, and if that fails, try to go for some other logic. And remember, you have only 30 seconds or maximum 45 seconds to do this. If you're able to get the answer, that's fine. Otherwise, simply leave it and go to the next one. Let us now take the last one here. 188, 186, question mark, 174, 158, 126. Let's go ahead with the differences. 188 minus 2 is 186. We're supposed to find out what comes in place of question mark. Let's take the differences between these numbers here. 174 minus what will give us 158? 174 minus 16 is equal to 158. And 158 minus 32 will give us 126. So if we try to observe, 188 minus 2 is 186, 174 minus 16 is 158, and 158 minus 32 is 126. Now we very well know that we will get two more differences here between 186 and question mark and 174. Only then these all differences will be following a particular fashion. But then if you try to observe the differences that we have got so far, 2, 16, 32, these are all powers of 2. That is nothing but this is 2 power 1, this is 2 power 1, this is 2 power 4 and 2 power 5. So maybe that is the logic between the given question. So if we try to take the other two differences as 2 power 2 and 2 power 3, we should be able to satisfy the given series. If that satisfies, we are through with the question. Otherwise, we need to go for something else. Now, as all are negative differences here, let's take it as minus 4. 2 square is nothing but 4, and then 2 cube here is 8. Now 186 minus 4. 186 minus 4 will be equal to 182. So the question mark here may be equal to 182. Now this 182 minus 8, if it is 174, then we have got the answer. Otherwise, we have to go for something else. And if we check, 184 minus 8 is 174. So very clearly, the question mark here should be replaced with 182. As the pattern here is minus 2 power 1, minus 2 power 2, minus 2 power 3 and so on. So the answer for this question here is 182. So mostly it's about finding out the differences and understanding what is the fashion or what is the pattern between the differences of two consecutive numbers of the given number series. So try to work in this way and find out the answer as quickly as possible. Let us now take the next set of examples from model 3. Now the example 6 here is 4, 2, 2, 3, 6, 15 question mark. That means we are supposed to find out what comes in place of question mark. If you try to observe the series here, it decreases, it is then constant and then keeps increasing. And you find that the increase is not a gradual increase. It jumps from 2 to 3, then suddenly gets doubled, then more than double and so on. That means here, instead of addition, the logic there is in terms of multiplication, or I can say the logic may be in terms of multiplication. And if you try it out and observe, the correct logic comes out as follows. 4 into half is equal to 2. 4 multiplied by half is equal to 2. 2 into 1 is equal to 2. 2 into 1.5 is equal to 3. 3 into 2 is 6. And 6 into 2.5 is equal to 15. So if you look at this half here is nothing but 0.5. So we can say this is into 0.5. So the logic goes as follows. Into 0.5, into 1, into 1.5, into 2, into 2.5. That means as you can see here, the logic is in terms of multiplication. And the multiplication factors are 0.5, 1, 1.5, 2, 2.5 and so on. That means it is increasing by 0.5 each time. So very clearly, 15 should be multiplied with 3 to get what comes in place of question mark. 15 into 3 we know is equal to 45. So question mark should be substituted with 45, or 45 is the answer for this question. So that is how, as you can see here, the question is based on multiplying each term to get the next term, and the multiplication factor increases by 0.5 each time. Likewise, we may have various other patterns. For example, into 3, into 4, into 5, into 6, so on. Or into 3, into 6, into 9, into 12. That is nothing but multiplication by multiples of 3 to get the next term. So we need to just observe this and get the required answer. Let us now go for the next example. That is 8, 9, 13, 22, 36, 63. Here we are supposed to find out which of the given numbers is wrong. That means what is that number which does not fit in the given series. Let us try to find out the differences between two consecutive terms and observe is there any pattern between those differences. 8 plus 1 is 9. 9 plus 4 is 13. 13 plus 9 is 22. 22 plus 14 gives 36, and then 36 plus 27 gives 63. So if you observe, the differences here are 1, 4, 9, 14, 27 and so on. And it is pretty obvious that the differences here should not be in a particular fashion. Why? Because one of the terms here is wrong, and hence two differences will be wrong. Why? Because if these differences are in a particular pattern, then we can say that all the numbers are correct. But since one of the numbers is wrong, the differences also here are wrong. So we need to just try out with various ways and understand what could be the probable logic. Now if you look at the first three differences here, 1, 4 and 9, we see that these are all squares of natural numbers starting from 1. For example, 1 is nothing but 1 square. So this is plus 1 square. 4 is 2 square and 9 is 3 square. So if we try to continue with this pattern, the next one should be plus 4 square, and then we should have plus 5 square. So let's assume that this is the correct pattern and check which of the numbers here is wrong. For example, 8 plus 1 square is 9, 9 plus 2 square is 13, 13 plus 3 square is 22. Up to this point it is correct. But then 22 plus 4 square will be 16, 22 plus 16 but not 22 plus 14. And 22 plus 16 should be 38, and the given term here is 36. So maybe 36 is the wrong number. But then that can be confirmed only if 38 plus 5 square balances to 63. So very well we know that even this is a wrong difference. Now 38 plus 5 square is nothing but 25. 38 plus 25 is actually equal to 63. So very clearly if we have 38 in place of 36, the differences become in a particular pattern, that is 1 square, 2 square, 3 square and so on. So hence we can say that 36 is the wrong number, and that should be the answer for this question. Similarly, the other pattern here may be in terms of cubes, plus 1 cube, plus 2 cube, plus 3 cube and so on. Or in terms of negative differences, minus 1 square, minus 2 square, minus 3 square, or minus 1 cube, minus 2 cube, minus 3 cube. Sometimes we get squares of only odd numbers. For example, plus 1 square, plus 3 square, plus 5 square, plus 7 square and so on. But as I've already mentioned, there is no definite method to get the correct pattern at the first instant. It's all about trial and error. So if you get the right idea at the right time, you'll get the answer. Otherwise, you just have to move to the next one. Let us now take one last example from model 3, that is 3, 4, 10, 33, question mark, 685. So we are supposed to find out what comes in place of this question mark. Now this series here is a typical one where the difference is a combination of multiplication as well as addition. Let me directly give you the pattern here so that you understand the logic behind that. 3 and 4, we see that the difference is 1. 4 and 10, the difference is 6. 10 and 33, the difference is 23. So the differences here no way form a probable logic. But then if you try to think divergently, for example 3 plus 1 is 4, but that 1 can be taken as into 1 plus 1. 3 plus 6 is 10, but that can be taken as 4 into 2 plus 2. 4 into 2 is 8 plus 2 is 10. Likewise 10 into 3 plus 3. So if you observe 3 into 1 3 plus 1 is 4. 4 into 2 8 plus 2 is 10. 10 into 3 plus 3. 10 into 3 30 plus 3 is 33. So we are able to understand that the logic here is into 1 plus 1 into 2 plus 2 into 3 plus 3. So the next one has to be into 4 plus 4. Now 33 into 4. 33 into 4 is 132. 132 plus 4 is 136. So we can say that the question mark here is 33 into 4 plus 4. 33 into 4, 132 plus 4 is 136. So question mark should be equal to 136. And the next one has to be into 5 plus 5. And 136 into 5 plus 5 will be equal to 685. So we are pretty sure that 136 is the correct answer. So the logic here is into 1 plus 1, into 2 plus 2, into 3 plus 3, and so on. Likewise, the other possible ways of giving the logic may be into 1 plus 1 square, into 2 plus 2 square, into 3 plus 3 square, and so on. And likewise, into 1 plus 1 cube, into 2 plus 2 cube, into 3 plus 3 cube, and so on. And likewise, there are many other possible patterns which can be used to form a number series. So it's all about understanding the pattern and getting the required answer. Let us now take up the fourth module from this topic, where we are going to discuss various typical examples on number series. Now the first example here is 1, 4, 27, 256, question mark, 46,656, and we are supposed to find out what comes in place of question mark. Now what do you think should be coming in place of question mark? What is the logic in this series? If you observe properly, this 1 here can be taken as 1 power 1, 4 can be taken as 2 power 2, 27 can be taken as 3 power 3, and 256 is nothing but 4 power 4. So it is pretty obvious that question mark should be equal to 5 power 5. Why? Because they are in the form of 1 power 1, 2 power 2, 3 power 3, 4 power 4. So next one, if we take it as 5 power 5, this is a particular fashion. It follows a particular fashion. So 5 power 5 is what comes in place of question mark. And we know that 5 power 5 is 3125. Otherwise, you can calculate that and find out what is the value of question mark here. And this 46,656 obviously has to be 6 power 6. We need not verify whether 6 power 6 is 46,656 or not. It is simple that if this is the pattern, next one has to be 6 power 6. And that can be justified by checking the units place. Any power of 6 will be ending in 6. And this number here also ends in 6. So we can say that this is 6 power 6. So let us not waste time in checking whether this is 6 power 6 or not. Let's go ahead with the answer as 3125. That is nothing but 5 power 5. The next question here is 7, 26, 63, 126, 215, 342. And we are supposed to find out which of these numbers is wrong. Or there is one number here which does not fit in the series. So what is that number? Now what do you think is wrong here? 7 or 26 or 63 or 126, 215 or 342? Now if you try to observe properly, this 7 here is nothing but 8 minus 1 or nothing but 2 cube minus 1. This is like 27 minus 1, which can be taken as 3 cube minus 1. 3 cube is 27 minus 1 is 26. Likewise, this is 4 cube 64 minus 1 63. So the probable pattern here is 2 cube minus 1, 3 cube minus 1, 4 cube minus 1 and so on. So next one has to be 5 cube minus 1. But here it is 126. 5 cube minus 1 is 124. So maybe this is the wrong number. It should be replaced with 124. Why? Because 5 cube is 125, minus 1 should be 124. But let's go ahead accordingly and see if the remaining two numbers are correct or not. If this is 5 cube minus 1, next one should be 6 cube minus 1. That is 216 minus 1, which is 215. So it is correct. And next one has to be 7 cube minus 1. 7 cube is 343. Minus 1 is 342. So we can say that 126 is the wrong number. Why? Because it should be 5 cube minus 1, which is equal to 124. So the wrong number in the given series is 126. Let us now look at the next example. That is 7, 11, 4, 18, 14, 15 and 5. Here we are supposed to find out what is the wrong number. As one of the numbers here is wrong, we need to identify which one of those numbers is wrong. If you look at the numbers here, 7 increases to 11, then decreases, then increases, decreases, increases and decreases. But then this increase and decrease is not in a proper flow. 7 is increasing up to 11, but suddenly it decreases. Then it increases by a huge value, that is up to 18. Then decreases slightly, again increases only by 1 and suddenly decreases up to 5. So there is not a proper flow in that increment and decrement. But then if you observe here, 7 plus 4 will be equal to 11. That means the addition of these two numbers will give us the middle number. Likewise, 4 plus 14 will give us 18. That means sum of 4 and 14 is equal to 18. So we find that sum of two numbers gives us the middle number. Similarly, 4 plus 14 gives us the middle number. Now if we go by the same pattern, 14 plus 5 should be giving us the middle number. But 14 plus 5 is equal to 19, whereas the given number here is 15. So we can say that 15 is a wrong number. It should be replaced by 19. So the answer for this question here is 15. The question was, what is the wrong number? Here, 15 is the wrong number. So this is again a typical example where we find that sum of two numbers gives us the middle number. Again, the sum of next two numbers gives us the middle number. That means sum of alternate numbers gives the middle number. So that's like a puzzle series where the pattern is really different from what we have been observing so far in the previous cases. But that's how it is. We have no method to get the direct answer. We only have to go for trial and error and check if we can get the right answer in 30 seconds or not. Let us now look at the last example here, that is 12, 17, 23, 33, 52 question mark. We need to find out what comes in place of this question mark. Now if we try to go by the differences here, 12 plus 5 is 17. 17 plus 6 is 23. 23 plus 10 is 33. 33 plus 19 is 52. But then the differences are not in a proper fashion. 5, 6, 10, 19 doesn't have a flow in it. There is no rhythm between these differences. But then if someone tries to observe the difference of the differences, then he gets the right answer. For example, 5 and 6, the difference is 1. So 5 plus 1 is 6. 6 plus 4 is 10. 10 plus 9 is 19. And now if you look at these differences, 1, 4 and 9, this is like 1 square, 2 square, 3 square. That is plus 1 square, plus 2 square, plus 3 square. So you find that the differences are not in a proper fashion, but the differences of differences form a particular logic. So going by that, we can say that if this is 1 square, 2 square and 3 square, next one has to be 4 square. So that 4 square here is nothing but 16. So 19 plus 16 should give us the difference between 52 and question mark. Now 19 plus 16 is equal to 35. And now if we try to apply this, that means 52 plus 35 should give us the value of question mark. 52 plus 35. So question mark will be equal to 52 plus 35, that is 87. So the answer for this question here is 87. That means question mark has to be replaced with 87. So this is another typical example where you see that the differences of differences form a particular logic. This is a very rare case, but then it may appear in the exam. And you have to think in all possible directions to get the right answer. But the time is limited. That is, we have only 30-45 seconds to get the right answer. So in that time, if you are able to work out and get the pattern, well and good. Otherwise, as I've mentioned always, simply leave the question and go to the next one, as there is no definite method which can give you the correct answer. So instead of wasting time on questions of number series, you can instead spend that time in solving other questions where there is a definite way to get the answer. So try out for 30-45 seconds always, but make sure you don't waste time more than 45 seconds. Remember, it's all about observation. These questions are completely based on the perception of the candidate. So you have to observe the logic. You have to feel the pulse of the question. Observe that whether the series is increasing gradually or is it increasing sharply or there are sudden changes, and then accordingly try to form the pattern there. If you are successful in doing that in 30-45 seconds, then you are through. Otherwise, you know what's the answer. Leave it and go to the next one. So practice well on these questions of number series. As I have already told you, there are infinitely many logics. I cannot say that the topic is over at this point. Why? Because we cannot discuss all the different logics that are there. But only with practice, you will be able to solve more and more questions in less and less time. So make sure that you practice on various questions on number series which are there in workbook and training guide, and see to it that you can get maximum out of it in that limited time in the exam. So practice well on this. See you in the next session. Thank you.